yesterday we learned the basic definitions for the Chapter 21 Type 1 and Type 2 error. Well, today we're going to start talking about, some deeper thoughts about those errors. And so I want to first start, and you don't have this in your notes, but I want to first kind of think about a problem that we had yesterday and then go from there. So let's remember that shipment problem that we had yesterday where you're the person who stands on the dock and you decide to accept the shipment or reject it and send it back to the manufacturer. So a type 1 error occurred when it is a good shipment, but we got a sample that made us think it was bad, so we sent it back. So it was bad for the manufacturer. So a type 1 error was bad for the manufacturer because they would have to then resend another shipment when the first shipment was actually fine. Okay, so type 1 error, manufacturer did not like. Now type 2 error is when the null is false. We failed to reject a false null hypothesis. So the null is false, which meant we have a bad shipment, but we failed to reject it and we think that it's good. So type 2 error is bad for me, the person who is in charge of accepting or rejecting, because now my company is going to be paying for faulty parts. Okay, so you could see that type 1 error in this case was bad for the manufacturing, whereas type 2 error was bad for my company. So that's what we're going to stem from today. How can you handle these types of errors when it might be better for one to happen more than the other, and who's in charge of that? So let's take a look at your notes on page 52. So we can see from the type 1 and type 2 errors homework that we did that certain groups benefit from particular errors, or some don't like errors more than others. So for that reason, it is important to understand the mechanisms, like mathematically, what's happening for type 1 and type 2 errors, because there are some things that we can control to change the probabilities of those errors happening. Okay, so here's things that we can control. When we run a test to decide if we're going to reject or fail to reject. So what do you, or the person who's ordering the hypothesis test, have control over? Okay, yes, but like in a hypothesis test in general, what do you as a person who's saying, I want you to run this test, what kind of things do you specify or have control over that in the hypothesis test? Okay, true. I can define what HO is, but I think I heard it. Somebody said, okay, good. We can control the sample size. Okay, and so that is one thing that will change some things for us. Okay, so we're going to discuss that today. Also, one other thing that we're going to discuss that we have control over is alpha. You know, they can tell you use an alpha of 0.05, or they can tell you use an alpha of 0.1 or 0.001. Okay, so whoever's paying for the test can decide how big they want alpha to be. All right, so that's important because those play into the probability of a type 1 error. And so let's review from yesterday what it looks like when we have a type 1 error. Okay, so let's redraw this. You're going to get used to kind of seeing these pictures. So type 1 error, the null is true. So all of our data is in here. Okay. If the null is really true, but we get a sample that causes us to reject the null, that's a type 1 error. So here's my question. Where is the sample that I get that causes a type 1 error? In this situation, where's the sample that causes a type 1 error? In the rejection region, which is the size of alpha. Good. So here is the sample that makes me reject a true null hypothesis. So therefore, alpha is directly, the size of alpha is controlling the size of this rejection area. Okay? So that means that alpha is the probability of a type 1 error. If they make alpha 5%, then there's a 5% chance that you will make a type 1 error. Okay? If they say alpha is 0.1 or 0.01, okay, whatever. So look at this guy right here. If the manufacturer is paying for this, what kind of alpha would he like? A big alpha or a small alpha? Yes, small. The manufacturer does not like a type 1 error because he gets good items sent back to him. So he would say, I want alpha to be small because I do not want you to commit a type 1 error. Okay? So see how you can control that. I want to show you a picture of that. So here is a digital picture. Let's see here. Okay, so we've got, this is the curve when the null is true. We just have one curve here because that's where the data is located. And so the blue area is the rejection region, whereas I showed a one upper-tailed rejection region. Can you see what their alternative was in this one? Or was there? It's a lower, upper and lower, so it's a two-tailed test. Okay. So I'm going to start with a smaller alpha. Okay, so you see this, see the small blue areas? So that's a small alpha area. And where this little black, where I'm circling right here, it's kind of hard to see this black thing right here. Let me see if I can get that little orange to show up. So there's a little orange there. That's the sample you get. Okay, the sample you get and run your test with. So based on where that sample is right now, would you commit a type 1 error? No, you would not. Why? Because you're not in the rejection region. Okay, so where this is right now, so at that size alpha, I would not be committing a type 1 error. But watch what happens, of course, as alpha increases, my type 1 error area increases, and so now this guy right here, what can you say? He is now what? Making a type 1 error occur. All right. So you have control over the size of alpha, or at least whoever's paying for that test, and that could affect the type 1 error happening. So therefore, alpha is not only the size of the rejection region, it is also the probability of a type 1 error. And so you can then change the size of alpha based on if you want that or not. Okay, let's move on to type 2 error discussion. All right, we're going to draw our pictures. We'll be drawing pictures again tomorrow, by the way. So with the type 2 error, what is the deal about the null hypothesis? It is false. So the data is not located right there. It's false. So no data there. Our data is located here in this alternative because the HA is true, and so that's where all of our data is located, is in that area. Okay. So let me go ahead and put my same alpha in there. Here comes my alpha. Okay. All right. So here is my question to you. Okay. I'm going to put a sample on there, and I want to know where is the sample located that makes a type 2 error happen. Where is the sample? It's in the rejection region? Ah, on the left side of alpha. Gotcha. Okay, here on the left side of alpha. Okay, so right there is where a type 2 error would occur, because that would make me fail to reject a false null hypothesis, type 2 error, type 2 error. So I would fail to reject a false null hypothesis, which is type 2 error. All right, so that is actually something here. This is a sizable area. I mean, we have got a measurable amount of area. And so that is a probability. And that is called, that area is called the probability of a type 2 error. Okay? So whereas alpha was the probability of a type 1 error, and then we can just draw an arrow here of this. This section here is beta, which is the probability of a type 2 error. Okay. So I want to take a look at that on our applet that we're going to show online. You actually don't typically have control of beta. You're defining where alpha is does also control beta. So let's watch this. So I'm going to put the alternative up there. And when I put the alternative up there, then this peach area shows up. And this peach area is beta. That's the area, that's the probability of a type 2 error. Okay? So right now I have a very large alpha. I'm going to make alpha smaller. So what do you think is going to happen to the size of the peach area, the beta? What will happen to beta when I make alpha smaller? Okay, let's see. So alpha's getting smaller. So look at what happened. So with a smaller alpha, the type 2 error actually increased. And so there will always be that relationship. So here's a small alpha. Alpha gets bigger. Beta gets smaller. All right. So we're going to kind of come down here and start a little visual aid of all the connections that we're going to be making today. And the first one we're going to be doing is our type 1, probability of a type 1 error, which is alpha, and our probability of a type 2 error, which is beta. Okay? And I'm going to say if alpha goes up, what does the probability of type 2 do? What does beta do? It goes down. Very good. So there's that relationship, and we're going to add to this as we go through things today. But there's a start of a visual aid that we can use to know the relationships. All right. Okay. So there you have control over the type 1 or the type 2 happening. So again, whoever's paying for the test can kind of manipulate that, you know. Say remember the manufacturer who makes the tapes that are supposed to help you quit smoking? If they're paying for the quote-unquote research on that to support their tapes, then they're going to set alpha at a particular level so that it looks good for them. Okay? All right, let's learn another thing. Let's learn a new vocabulary word today, and that is this item called power. So power means that you had the ability to reject that null hypothesis if it is indeed false. And that's actually written there on your page. So power is the ability to reject that null hypothesis if it is indeed false. So if it's false, don't you want to reject it? Heck yeah. Okay? If the jewelry is toxic, don't you want to reject the null hypothesis that says it's okay? Heck yeah. I want to reject if it's indeed false. So I have a song to help us remember that definition. So here we go. Okay, so you can do the little echo back on it, and I'm going to get really intense with this because you know it's power. We need more power. Anybody remember that from the Einsteins? Little Einsteins, need more power. Anybody watch that with? Okay. Need more. Okay. It's kind of borderline. Y'all might have missed it unless you babysit some kids. All right. So here comes our power song. To reject the no, if it's false indeed. Okay, here it is. Power is the probability to reject it's false indeed. Okay, so that's what you want to do. You want to reject the null if it's false indeed. All right? Okay, so hopefully that'll help you remember the definition, or I'll sing that to you as we go along. Okay, so looking at our picture here, I want to know the area. I want to know the area, the shaded in space where power occurs. So let's take a look at our picture here. The null is false, and we reject it. Where is that occurring? Not in the yellow. The yellow is making us not reject it. To the right of that alpha. Yes, this here. This is power. Okay? Power. All of these samples in here lead me to reject the null hypothesis if it is indeed false. So this area is power. Okay? So power is that probability to reject the null. To reject the null. If it's false, indeed. Okay. So here we want to reject the null. If it's false. Alright, so we want power to be bigger and bigger and bigger. So of course we are interested in what can we control to increase power. So let's go to our little online thing here. And I'm going to put in the red area, which is power. Okay, and there it is. Alright, so what are we going to control? Alpha. So let's control alpha and see what happens to power. Alright, right now I have alpha set really large, so I'm going to make alpha smaller. What do you think is going to happen to power? Decrease? Left? Okay, I don't know, let's see. Okay, alpha's going smaller. Here we go. Alpha smaller. Alpha smaller. What's happening to power? Power got smaller. So alpha smaller, power gets smaller. So the opposite, of course, if I make alpha bigger, what's happening? Power gets bigger. Okay. And let me tell you, there's a direct relationship between this yellow area and this pink area. Do you see that connection between them? What is the relationship between the yellow and the pink? They what? Yeah, I heard it over here. As one goes up, the other goes down, because what about them together? What? They are complementary. True. I still haven't heard it. I mean, maybe y'all are saying I don't know. They are indirectly related. What do they create together? One. Thank you. Oh, this is 100% of the data right here. Okay, so basically, let's see, power plus beta is all of the data. See? So power plus beta equals all of the data. Or in other words, it equals 1. Okay? So it is very common to see this relationship. A lot of times people will say power equals 1 minus beta. Okay? Alright. Because power plus beta is all of the data. Okay. So let's go down here to our little picture that we've been building some relationships on and add to this. We said as alpha goes up, type 2 goes down, but let's put power in the mix here. What did we say? Let's do this. Let's make alpha go. As alpha goes up, what does power do? Power goes up. All right, so here's how we're going to write this. This is the way that you increase power. And we'll have another thing we'll add to this shortly. So here's the ways you increase power. Alpha goes up, type 2 goes down. Okay. All right. I have two more relationships to show you. One, let's start with the thing that another item that we can control. What's the other item that we can control? What? Sample size, N. Very good. And so I don't have anything in your, I have a picture here to go off of this. So let's take a look here. Look at the, it's hard to tell because it's very subtle, but there is a difference between this top picture and this bottom picture. Can you tell a difference in those two? The bottom one looks what? What? It has a larger N because what about it? It's taller and skinnier. It's less varied. Okay, good. So this down here has a larger N because it has a smaller standard deviation. We see it's less varied. Okay, this one is less varied. It's taller and skinnier, more closely clustered around the mean, all that good stuff. Now, I actually am just changing one variable. So on these two pictures, alpha is going to be staying the same. All right, we are only changing one variable. Alpha will stay, let's say it's at 5%. So the blue area up top is the same as the blue area down below. It looks a little bit different shape because of the curve of the shape. Okay, so based on that, let's talk about what's happening to type 2 error and what's happening to power. So what color on this board would represent type 2 error? The red. Good. Do you see this top red area? What's happening from the top red area to the bottom red area? It's decreasing. That's easy to see. So as N went up and it sucked in the curve, your type 2 error went down. Okay? And then what color is representing the power? Green. Yeah, all that green. Oh, yeah, I guess, which is the whole ultimate shaded blue. Okay, yes, gotcha. Okay, so it's a little bit difficult to tell because of the difference in their shapes. However, you know if type 2 goes down, what's power doing? They're inversely related, so it's going up. Okay, very good. So, in summary, as N goes up, our type 2 goes down and our power goes up. So let's add that to our picture. Okay, so here's our picture. What we're going to do is, didn't I tell you on there, alpha stayed the same? Didn't I define, oops, sorry. Remember I defined on there that we kept alpha the same? So that didn't change. If we just change one variable, in fact, so I'm going to write it over here, N affects standard deviation, because I don't want to put it underneath the alpha because alpha didn't do anything. So, but this does, the arrows are applicable. As N is going up, the standard deviation is going down, and what's that making happen? Beta is going what? Down, and power is going up. Okay, so that's our little picture. That's the finish of our picture. That's all the relationship that we know so far of the things we can control, so we're going to practice that. So turn the page, or cover up what you've done so far, so we're going to practice this a couple times. So let's write it right here. So without looking, see if you can remember what it should look like. So put it up here at the top. Okay? Did you get that? Okay, then we're going to do it one more time, so maybe cover that up. Just making your practice. Come down here to the bottom. I'm going to draw a line down the middle because I want you to recreate the increased power one here. And then sometimes you might be asked the opposite. Sometimes you might be asked, what happens to power as N goes down, or something like that. So I want you to draw the flip side of this the decreased power picture. All right? See if you can't make the first one and then make the second one from it. Okay? So on my decreasing one, what should my left arrow be? Down. And then the top arrow, or the right arrow is, sorry, going up. Okay. So there you go. So in my mind, that's a visual aid that you can jot down real quickly and then remember all the things of how the waste items affect you. I've seen I see this written on the quiz, on the test. When those questions occur, kids go down and jot that down. Even when you get to the AP exam, and you come across a power question and all that relationship, you jot that down real quick and then you're able to answer the question. Okay, now there is another thing that can happen. You actually do not have control over it, but there is one more thing that can control power, that can change power. So I want you to go to your homework part 2. We're going to use this problem so I can demonstrate another thing that can change power. So here we go. Okay, so let's pretend we got this situation here where you're the dock manager person and you are accepting or not accepting a shipment of children's jewelry from China. Well, the FDA says the lead level can be, if it's at 0.3% or less, it's acceptable. But if we have a sample that makes us think that it's greater than 0.3%, we think it's too toxic and we will send it back. Okay. So here is a visual aid to help us understand this new situation and how power is changed. Okay, so take a look at my picture here. We're going to say that the null hypothesis is false. So you have a toxic shipment there on your dock, okay? And you're about to take a test of it. So it's supposed to be 0.3%. It's not. In fact, the average of that shipment is 0.6% lead. So it's just a little bit more toxic. It's not whacked out crazy, okay? So I want to take a look at I probably didn't draw that very well. Oops. Hold on, just pause. Hold on, just okay. All right, I think it just helps visually to make that a little closer. Okay, so there is where our data, the blue is where the data is. That's the 0.6% lead, not incredibly toxic. So here I am going to put in the alpha. So here's our alpha. So where is power? Where are the samples that will lead me to reject a false null hypothesis? To the right of alpha. Okay, good. So all of this right here is power. Okay, good? So this is probably, a medium-sized power. So this is you got some power going on. But do notice this area is a little concerning, right? Because look at how many samples would, would give us a type 2 error. That's quite a bit. Why is there so many samples that would give us a type 2 error? Because the alternative is so close to the null hypothesis. Okay? So it's likely that we're going to end up accepting that shipment even though it is indeed a little toxic. Okay. But let's look at what happens when the alternative is very far away from the null. Let's see what changes down here. Do you see this? The left is the 0.3% toxicity, but the right is like 5%. So that's huge. Now let me make my alpha the same. So let me draw that in the same place. So at the same alpha, okay, what is this? Where's my power? Yeah, it's close to 100%. I mean, probably every single sample I would get would lead me to reject the null hypothesis since it is indeed false. So this is very high power. So the moral to this story is, as your alternative gets farther away from the null hypothesis, power does what? Increases. Very good. So as the alternative gets farther away, it increases your ability to reject that false null hypothesis. Okay. So that one I don't really have, well, I don't have it on my picture, but I do have it in this table down here. So let's go ahead and complete this table together, and then I'll let you start on the assignment. Here we go. First of all, these two things should go together. N going up and standard deviation going down. I mean, those are the same essentially, right? Okay. Let's do alpha. Let's do this alpha line first. Let's do this one. All right. Alpha goes up. So tell me, and look, I even have the picture drawn there for you. What does that do to type 1 error? It goes up. Okay. What does that do to type 2 error? It goes down. What does that do to power? Alpha going up is increasing power. These are the ways you increase power. Okay. All right. Let's do the one that's not on the chart. Move the alternative far away from the null. That's this page. So what happens as my alternative got farther away from the null? What happened? Power increased. That was the key to this page. Power increased. So I come down here and I said power went up. If power goes up, what does type 2 do? It goes down. Now, do you recall what I did whenever I drew the picture? What did I do with my alpha? My alpha stayed the same. I mean, there really is no type 1 error, because type 1 error has to happen when what? Type 1 error occurs when the null is true, but it's not true. Okay, so that really doesn't apply here. All right, let's do the last one. What happens as N goes up? So we can use our little picture down here. N goes up. Okay, but do recall that on this picture here, what did I do with my alpha? I kept it what? The same, because I didn't want to change more than one variable at a time. So let's keep this, let's not change this. So we're just going to do that. We did not affect alpha, so that's going to be that way as well. All right, but what happened to the type 2 error? It did go down, and what happened to the power? It goes up. Okay, good. So all of those are ways that type 2 goes down, power goes up, and then of course you see the way alpha affects type 1 error. All right. Okay, so tomorrow we're going to get 3 pieces of blank paper, and we're going to use 3 markers and do all that kind of fun stuff and make ourselves three separate picture things we can keep in our folder to help, another way to help us remember this same stuff, okay? But for now, I want you to do pages 55 and 56 for homework, or actually, you got 20 minutes here, so you could do some classwork. But let's take a look at 56 real quick. On this page 56, just FYI, this top problem here is running a test to see if the university gets federal funding or not. Okay, so you have to run a test to see if it gets federal funding or not. Okay, so I want you to start working on that, page 55 and 56.